Hi guys, welcome back. We are here to solve this exercise where we are going to avoid race condition in reader-writer problem. So we are going to write a code for this. So we are setting ourselves up. So basically we are going to have multiple readers and multiple writers, and we are going to use data in the critical section. We are just going to increment the value of data and maybe display the value of data. Then we go to make reader and writer sleep for 1 second, and we are going to use semaphore, right? So before I start writing the code, what I want to do is I want to go back and dry run this for you very quickly, because I believe that since I'm going to use this code exactly as it is, so I don't want to spend a lot of time when I'm writing code to do a debug over there. So I'm going to debug over there here for you guys, and when I run over there, I'm going to show you different outputs over there. I'm going to write a code in front of you for sure, but then I'm going to show you different outputs over there, so that you understand that how different writers are blocked and how different readers are blocked when we perform different actions using different threads. Okay, so what I'm going to do right now is I'm going to debug this. So what we want to do is basically, so we have different readers and writers, and there is a critical section. So let me have a critical section over here. So this is a critical section. uh, let's assume we have a reader R1 and we have a writer W1. They both want to enter this critical section, and we want to make sure that only one of them is there at one time. I'm going to debug this using binary semaphores. So I'm going to use binary semaphore, which is either 0 or 1. So I'm going to use that, and you can try the other one. Since I have explained well the count semaphores over here, counting semaphore over here, so I have explained that quite a lot over here. So I think you can, after I run the code for you for binary semaphore, you can try the counting semaphore. So since I have not explained a lot binary semaphore, I want to run the code in binary semaphore, so that you get an idea of both of them together. All right, so so this is what we want to do, and as I mentioned in the theoretical section as well, we are going to have two semaphores. So I'm going to have RW semaphore, and I'm going to have a mutex semaphore, right? So as I told you in the theoretical part as well, I'm going to have multiple readers, and I'm going to have multiple writers, and I'm going to use this RW semaphore to be shared between readers and writers, and mutex for between the readers, right? So when we solve this problem using binary semaphores, we normally initialize both of these semaphores with 1, right? So they are initialized by 1. So RW mutex is 1 and mutex is equal to 1. Both of them are semaphores. So what happens is, let's say reader wants to enter the critical section first. So reader came first, and we are going to call wait. Whenever I am going to call wait on any of these mutexes, what will happen is it will just decrement the value, right? So if we go back, if you see over here, if I call wait, the value of semaphore will be decremented, right? And for signal, value will be incremented. This is exactly what I'm going to do. So I have wait over here, wait of mutex, which means that I'm going to decrement the value. So I'm going to decrement the value of mutex over here. So I will just decrement the value of mutex from 1 to 0, right? Now and let me take a read count as well. So let's say RC read count, and let me initialize this with 0. Read count plus plus, which means that I have a reader now, which means that I will increment it by 1 since one reader has entered. Then I will see if read underscore count is equal to 1. Read count is equal to 1. Yes, that is true. So it will enter this if statement, and what it will do is, since reader is there now, we need to somehow block our writer, right? So I'm gonna do this wait RW underscore mutex, which means that I'm going to decrement the value of R underscore mutex, which is RW. I'm gonna say, and let me decrement it to 0. So it has been decremented to 0, right? So since it has been decremented to 0, now if I go to the next statement, what will happen is I will do a signal mutex, right? Signal mutex means it will increment the value of mutex. So I'm going to make it 1, right? Now after that, I'm reading my critical section, right? So I've entered the critical section over here, and the reading is being performed, or reader is still reading. While it's doing that, at the same time, let's assume the writer has entered, right? So writer has entered and it wants to go to the critical section. So this is the writer code, right? So this is the reader code. So at the writer code, what I'm going to do is, again, it will do wait rw underscore mutex, which means that it has to decrement. Wait means decrement, right? So it has to decrement rw underscore mutex, or rw. But rw is already 0. We cannot decrement it further because it's a binary semaphore. It can either be a 0 or a 1. It cannot go to a negative value, which means that it's already a 0. I cannot further decrement it, which means that it's stuck here. It's stuck here, right? So it's stuck here unless and until this value is becomes 1. I mean, because it becomes 1, only then it can be decremented to 0, right? So it is stuck over here. It won't be able to enter any critical section. So that's how we stop writer from entering the critical section when reader was already there. All right. And then same things happen. Then we have an exit statement, exit section over here for our read count as well. And once it's done, then it will allow the writer to enter. So I hope you guys do understand this, because I have run several algorithms now and I really want to go to code now to write the code for you, so that you guys can actually understand how this works, right? So I'm going to use exactly same code for these reader and writers, except that I'm going to use some functions which are taken from Semaphore library in C language. So I'm going to use that, and I'm going to use this code as it is, since this is a very popular algorithm which is available. It's a textbook algorithm, so it's available everywhere. And normally operating system developers and third-party developers, they use this code as it is. They don't change it at all, unless and until they want to achieve something extra, which this algorithm cannot do. So I'm going to use exactly same code for you, and I've already explained this code for you, and I'm sure you guys can go through the rest of the code where we have exit section. Exit sections are normally not very complicated. It's just the entry section that becomes complicated sometimes, but if you know the entry section, then exit section shouldn't be a problem. It's just a decrement to make sure that RC value goes back to 0, and then we have we are putting the flags back so that RW becomes 1 over here, again incrementing the value of RW, which will make it 1. And since it will become 1, now when writer checks this, since it's 1, it can decrement this value. Since it's a wait means decrement, it can decrement the value to 0, and then it can enter. So I hope you guys can understand this exit section. And yeah, that's pretty much it. This is how we debug. This is how we make sure that only one of these readers and writers, they are in the critical section. And what I want really you guys to do it, since I have done one of the cases for you where there was one reader already in the critical section and writer came and it was not allowed to go in the critical section, try to do it other way around, right? Try to do it debug it the other way around. When writer enters and then reader wants to enter, try and do that way, and then do it with double writers also. So 2 writers, they want to do it together, and then do it for 2 readers also, so that you guys understand how it works. All right, try to do that. What I'm going to do is I'm going to start writing the code for you and see how it actually works using different threads. All right, so let's start writing the code for reader and writer using Semaphore in C language. So oops, I'm gonna save this file as, so I'm gonna save it in temp. Let me save it as reader underscore writer semaphore.c. Okay, so let's include the libraries, all the required libraries. So include, and let's make it stdio.h, stdio.h. Let's include the other ones, stdlib.h. Let's put a space. Okay, and let's include thread library as well, because we are going to do it using thread as per the description of our exercise. So I'm going to use pthread.h as well. I'm going to include, since I'm going to use sleep as well, so I'm going to use unistd.h as well. And we want to include the Semaphore library. So C has built-in Semaphore library for us, so we don't have to write them from beginning, right? So I'm gonna use that semaphore.h. So I'm gonna use these libraries just to make sure that everything is included. Yeah, everything is fine. So what I want to do is, if you remember, if I go back to our reader writer, this is the exact code I'm gonna use. I'm gonna make sure that we use this code under the threads. All right, so let's do that. So what I'm gonna do is, let me write a main method first of all. Int main return 0. So over here what I want to do is, first of all, I want to have some threads. How many threads are mentioned over there? Let's see. Okay, how many threads are mentioned? Is there any number? So there are no numbers mentioned. Let's take maybe 3 or 5. So you know how to create threads. We use pthread underscore t, and I'm gonna use a reader thread. Let's make it an array of 5, and I'm gonna use a write one as well. So one for read, one for write. I'm gonna use 5, array of 5, and we have to make sure we create these threads. So I'm gonna use a for loop, int I is equal to 0. I'm gonna use maybe 3 or 4 threads, maybe 4, maybe 3. Yeah, even with 3 I'm gonna create 4 threads since I'm starting from 0. So I'll do this, and I'll do I++, and I'm gonna use a method to create thread. If you remember, that was pthread underscore create, right? And inside this I have to pass the threads over here, which is in this case, which case we are going to do. So let's start with maybe a writer. So writer wants to enter a critical section, and then reader comes in. So let's do that case. You can try the other cases as well. So I'm going to make sure that writer comes in. So I'm going to use the array address of this array. So which is, since I have to pass the address, if you remember correctly, last time we did this for threads, and I'm going to pass my first writer inside it. Default parameters I'm going to use. I'm not going to add anything else. And I have to create my function, some function here, maybe let me call it writer underscore function maybe. And if I have to pass some parameters, which I have to, right? So I'm gonna fill these things in a while, because I still have to create that function, and I have to see what parameters I have to pass. And let me do the same thing for the reader also. So I have to create a thread for readers, maybe 4 readers starting from 0 to 3. So this for loop will create for us 4 writers and 4 readers, right? And I'm gonna call this function a reader function, and I'm gonna create the function in a while. Then I might have to pass the values over here, because at least we should know which writer is this, which thread is this basically. So for example, thread 0, we can pass that value over here. If we don't want, it's just fine, but let's see what we have to do. And then we may have to join it, right? So if you remember, we have to join the threads as well to the main thread, remember? So we have to do that. So same thing, same for loop I++, and we need to join them. For that we use pthread underscore join. I hope you remember this, and I hope you understand what I am doing. I have started with threads just to make sure that you guys understand what we do, at least the idea of this. I don't want to complicate it a bit. So very simple code for threads. You guys have already done that, and I have seen some of the students approaching me asking me about this, and I can see that they have actually completed this. They dropped me an email. So this code shouldn't be a problem. It's a very simple code of creating different threads. So I have created 2 set of threads, one for reader, one set for readers, and one set for writers. We created threads for them. Then what we did is we have just joined them back to their parent. That's it. And since, yeah, that's pretty much it. Now what we have to do is we have to create our reader and writer functions, right? I'll start with writer since it's a smaller function, this one. So let me create it up here. So I'll do if you remember, we have to create a pointer function, right? So writer underscore function. Inside this, since I want to maybe get the ID of a thread, which I'm passing over here, so that my output would be thread 0 has written this, thread 1 has written this, something like this. We'll see what we have to display. So we have this thing over here, and I want to write the code for my writer, which is something like this. I'm going to use exactly same code. It's just that instead of wait, I'm going to use the function from Semaphore library, which is sem underscore wait. All right, sem underscore wait, and inside this we have to pass the address of that. So we don't use exactly like that. That's why I wanted to write it for you, so that you actually understand how we perform that in actual. So let since it says we have to comment also, so I'm going to say entry function, entry section. My entry section is going to be this one, right? This is going to be my entry section. So for this one, I have a special function in Semaphore library, which is sem underscore wait, and I have to pass to it the address of my reader writer mutex. All right, so rw mutex, rw underscore mutex, and I have not created that, so I have to create that. I have to create some global variables, if you remember. So I have to create a sem underscore t, if I'm not wrong. We'll get an error, no problem, we can fix it later. So I think it's sem underscore t or semaphore underscore t, we'll see that. So sem underscore t, which is a part of this library, and it will help us in creating our mutex lock. So I'm going to call it mutex, exactly same thing which we have over here. So we have mutex over here, and then we have rw underscore mutex. So I'm going to create both of them. So let's do that. So mutex, and I'm going to create an rw underscore mutex as well, just to keep the names similar. And as per our exercise, we have to create a variable data, right? So let's create that data variable also. It's just going to be an integer data, and I'm gonna start it with 0. And as you remember, we have to have a read count also, right? So read count is equal to 0 as well. So I'm gonna do that as well, right? So we have these variables now available for us, and we can use them in our code. So I hope this is clear. We have just taken some global variables so that we can use them throughout our functions. So sem underscore wait, which is sem underscore wait, which is the wait over here, so for decrementing the value of rw underscore mutex, and rw underscore mutex is this is passed as address. So if you see the definition of sem underscore wait, which I want you guys to go ahead and see, and I want to see how you guys actually do that. So try to go and search for sem underscore wait through terminal. You can Google as well. So they have libraries on Google as well for Semaphore. So you can Google that from the documentation of C, or you can go to terminal and find that information from there. But since I know that it takes sem underscore wait takes the address of the mutex, Semaphore mutex, rw mutex. So I'm going to do that. So rw underscore mutex, this is what I want, which is exactly what we have over here. So once we have that, let me put a semicolon as well. Once we have that, we have to go ahead and work on our critical section, right? So this is the only entry section. It's an entry section. Let's call it an entry section. Yeah. So entry section, and let's write the critical section now. Critical section. In this critical section, we have to do only two things. First thing is to increment this data and then sleep the writer for 1 second. So this is what we are going to do. We are going to do data plus plus, very simple, and we are going to do sleep of 1. So sleep of 1 means it will sleep for 1 second. Very simple. Let me display the value of data as well. Otherwise, we won't know what the value of data is. So let's display the value of data as well. So data written is the value of data. Let's call it yeah, t, and the value of data, right? So something like that. So we now have the written data, and we have written the critical section, we have written the entry section for writer, using very similar code which we have over here, and then we just have to write the exit section, which is signal, which is to increment the value so that it gives an indication that I am done with the critical section. Now reader or writer, any reader or writer, they can enter it, right? So let's do that. Let's comment that also, and I'm going to say exit section. And for this we have a special function as well, so we don't have to worry about writing this function. We have these functions in Semaphore library. I'm going to do sem_post. So this function is called sem_post instead of signal. It's called sem_post, and I'm going to pass the address just like what I did up there, rw mutex and semicolon. This is what we have to do, and that's pretty much it for our writer function. Yeah, it's yeah, that's pretty much it. So that's it. Let me check once again just to make sure, forget about this loop. So we have wait, we have written our data, shown the data, and put a sleep statement, then we have done this. I think we are good to go. We are good to go. So let me write the reader function as well, and that is going to be a bit lengthy since we know from here this is the reader function. So let's go ahead and write that. So what I'm gonna do is just what I did for my writer function. I have to create a new function for that, then do all these things, and okay, let's do that. So let me call it void static reader and underscore function, reader underscore function, and the same thing, void static thread. But we haven't used static thread inside our writer function, which we should do just to make sure that we have threads passed properly. We'll do it later. Let's work on this one first of all. So okay, so we have this. So first line would be wait mutex, which is to decrement the mutex, right? So for wait we have a special function which is sem_wait, and inside this we have to pass the address of mutex, right? This is not rw mutex, it's mutex, right? Okay, and then we have to increment the read count. So that's straightforward. So read underscore count plus plus, that's good. We are done with this. What else we have to do? So we have to check this read count. If it's equal to 1, then we make sure that our writer, which means that the reader has is planning to enter, and if it's entering, then you have to wait. Okay, writer has to wait. Although in this case we are going to make sure that our writer enters first, but in case reader enters first, this code has to be there. So if read underscore what happened? Okay, let's do it again. Okay, read underscore count is equal to 1. If it's equal to 1, then we are going to do make sure that it waits. So it's sem_wait, and we have to pass the rw underscore mutex because it's for the writer, right? So let me check quickly once again. That's perfect. Okay, that's excellent. So it should do that, and we know that. And after that we have to do an increment, right? So we have to do an increment for the mutex. By the way, we need to do commenting here, so that maybe because I have to upload this code for you guys also, so I need to comment it. So this is the entry section for reader, and you still have to write the critical section. So this one is this, then sem_post is for the mutex, if you remember from the code. So we do this from here. That's pretty much it. This is our entry section, and we are pretty much done with the entry section, if I'm not wrong, here. So we are done with the entry section. Yeah, we are done with the entry section. Just need to enter our critical section now. So critical section, and I'm going to do what I'm gonna do. So I'm going to just maybe print, since I'm going to just read. So reader is not going to do any increment or decrement to our data because reader is just reading. So I'm just going to do a printf, right? So let me do a printf data read is, so let's do that, and let's read the data we have, and I'm going to do data, and the data going to work over here because we have taken data as a global variable, so it will work in all of those functions. So this is critical. We have to make a sleep also, yeah. So as per our requirement, we have to make reader sleep for 1 second also in the critical section. And that's pretty much it for the critical section. It's quite easy, critical section. Now we have to write an exit section also. If you remember, there is an exit section for this also, which is this one. We have to write that also, so that once reader is done with the critical section, it has to tell our operating system that I am done, so another reader or writer can enter. Readers can anyways enter, but a writer can enter. So weight of mutex we have to write over here. Okay, so we have to do sem underscore weight, and that is mutex, and then we have to do a decrement of count, if I'm not wrong. Decrement of count, yeah, and then count is equal to 0. If it's equal to 0, then increment rw mutex so that writer can use it. Okay, so this is this, and let's use an if statement now. So read underscore count is equal to 0. If it's equal to 0, because it has decremented, we checked the increment over here and did a decrement in rw underscore mutex, and if it's 1 now, we have to increment, right? So that mutex can, since it's a binary semaphore, it has to decrement, or it has to decrement then. So if I have 0, it cannot decrement, and then writer won't be able to enter. So what I have to do is I have to increment the value of my rw mutex, which I can do using sem underscore post, remember. So we have to do rw underscore mutex, and we have to put the address of that, and that's this, and what else we have, this is this, and then we have to pass this. Okay, that's perfect. So now we just have to put sem underscore post, and that is for mutex, right? So that is for mutex, and we are done, right? We are done with this. It's just that I need to pass I can pass the argument. If I don't want to pass the argument, then I can work without that as well. I think I'm pretty much done. I just need to compile this and see how it works, and let's see if we have any errors. So let's do that. Okay, so let's compile this, and I hope you remember how to compile it using pthreads. So I'm gonna do gcc, what's the name, it's reader writer semaphore c, and you know we need to include pthread over here. Then we have to use output. It's better to give the name of give a name to your output like this, otherwise it will just do a dot out. Oh wow, it compiled without an error. That's excellent. That's an achievement. Okay, so let's run this and see what's going on, and let's see. It's not working. What happened? Okay, let's see why it's not working. Okay, we have to make sure that our functions are called properly. We have to make sure that values are displayed properly. I think it's stuck somewhere inside the sleep. Let's go through here. Okay, so we have created threads, fine. We have oh yeah, we have not called these functions. We have not actually initiated our sem underscore using our sem underscore init. Yeah, so what is happening over here is everything is working fine. It's just that our semaphores, which we have created over here, we have not initialized them. If you remember, Oh, I have just if you go back, rewind the video, you'll find out that I said that we need to initialize rw underscore mutex and mutex by 1. We have to do that. We didn't do that. um, that's why it's not working, and there is a way to do that, and this is the better way to do that. And since we have to tell that this is our shared mutex, this is our shared mutex between our readers and writers, so there is a better way of initializing this, which is by using a method, and it is highly recommended you do that. Init sem underscore init, and you have to pass over here the address of rw underscore mutex, and you have to let me show you very quickly what I'm talking about. So it's info sem underscore init. Yeah, so we have to initialize our semaphores, right? So in order to initialize your semaphores, you have to use something like this. This is the function which is part of this library. So this is how we initialize our semaphore. So it takes the semaphore first, the pointer, the address of the semaphore. Then int p shared means we need to tell over here if this semaphore is shared or not. If it's shared, then it will be shared between different processes. If not, then obviously it won't be shared, and we give it a initial value as well. If you read, these are the descriptions of this. So it says the p shared argument indicates whether the semaphore is to be shared between the threads or a process or between the processes, right? So since we are using threads, we need to do it this way. If p shared has a value of 0, then semaphore is shared between the threads. So we need to put a value of 0 over here if it's shared, which is in our case, and we put an initial value which is 1. Remember, we have to initialize them with 1. So this is how we're going to do it. So where it is, it's here. So we need to put a value 0 to tell that it's a shared mutex, and then we put an initial value which is 1. And I'm going to do the same thing with my mutex also, because mutex is not shared between readers and writers, but it is shared between readers, right? So I still have to do something like this. I think I'm done. Let's exit that. Let's compile it again and see what's going on. Still not working. No worries. It is working. It is working. It's everything in one line. That's the only problem. So let's put /n. So I'm gonna do a /n over here. I'm gonna do a /n over here, and let's see what is going on. Okay, let's compile again. Let's run again. So data written is 1, data read is 1, 1, 1, 2, 3, 4. Perfect. That's exactly what we wanted, right? So okay, let's see what happened. So since what we did over here is we called our write first, which means that this thread will be created first and run first. And once it's created, it went to the writer function, which is over here. What it did is it checked if somebody is in the critical section or not. Nobody was there, so it did data plus plus, which means that's why it's showing 0. No, it's showing 1 because data was 0, and it incremented. That's why it's showing 1, and then it printed that value, and then it went to sleep. Right? You might have seen when we were displaying the output that it waited for some time before showing the next value. Then it's done. Then operating system, what it did is, since I have different cores, now it's very difficult to predict what's going to happen, because operating system is going to provide different processors at different times. So you might not see exactly same output, because it totally depends upon operating system when it's going to use which thread, right? So then what it did is it brought some readers. So it brought some readers. So there were some threads, 3 threads for the readers also. So it brought some threads also from readers, not 3, 4, from 0 to 3, and they all read that value in the data, which was 1, because next write has happened after everything was read, which is absolutely fine. This is what operating system is managing. What we can do is we can try to maybe comment this and see what will happen. Let's compile again. Let's do this. Yeah, I mean, yeah, So we don't have a control over that, right? So we don't have a control over that. That's why what is happening is, what I'm going to do is, let's not make this sleep. So if I do now, yeah, you see, now we have a different output because I commented the sleep, where it is, I commented the sleep in red. So reader functions thread was not sleeping, so that's why first two reader threads, they read the value 1 because 1 was incremented for writer. Then writer thread ran, it incremented the value to 2, then it incremented the value to 3, and in that time operating system has provided the core, the processor, to the read thread again, so it read the value 3. Then it provided the core, the CPU, to the writer thread. It incremented that value and showed that value, and then it gave the turn to read that value. So I hope you guys understand this is what is going on. This is exactly what we wanted to do, if there is no other requirement from the exercise. So yeah, that's, I think, yeah, exactly. So we are just doing this. So instead of just incrementing this, you might have something else, maybe reading to file, writing to file, downloading a file from internet. So you can replace this critical section code by whatever code you want. Entry section code and exit section codes, they normally stay same unless and until you want to do some research, you want to build some other algorithm. That's a different scenario. But normally the entry section code and exit section codes, they normally remain same. And critical section code, obviously whatever you want to do inside, you can change your code according to that, right? So this is what is happening. I wanted to keep it very simple for you. This critical section, it could be very well, this is the main section basically, and it can be very comprehensive. It can be complex as well, but I didn't want to do that. I wanted to keep it very simple so that you guys actually understand what is happening in the critical section. And this is what we did. We just incremented the value in the writer function, displayed that value, and the writer went to sleep, and reader was just reading that value in the critical section, doing nothing. And I just commented the sleep also in the reader just to make sure that we read differently. Try to do different experiments on this. I hope you guys understand. It's not difficult. I tried to make it very simple for you. Just wanted to hide a lot of complications from you. I could have created a structure of processes, and inside that processes we could have created a control block and added some more details to that structure and run that process inside our threads, run that process for our muteces, for reader writer. But I didn't do that because I wanted to keep it very simple. I just want you guys to understand and relate the theoretical part with the practical exercise, and this is exactly what developers are doing. This is how they are using it. So this library and this thread library has saved us a lot of things. We didn't have to do this whole stuff. We just use libraries to use them. Similarly, creating threads, it's a mess when you do it yourself. It's not easy. So pthread has done this stuff for us, and then we have joined those threads as well. So it's pretty easy, this code. When you're using libraries, it's only a couple of lines of code. It's not too much. I mean, since I've given a lot of enters over here and there, so it's around 50 lines of code, which is not too much at all. If you are understanding, you can easily, I mean, you can make it more compact if you want. So I hope you guys understand this. Please make sure that you do not miss any line of code which you don't understand. I tried to explain almost all the lines of code to you. That's why I put this lecture in such a way that we have a lot of algorithms going on, so that if you don't understand one of the concepts, you can understand at least that concept in the coming algorithm. And they are pretty similar. If you see, just few things changing here and there, but the major concept behind that is similar, because we are solving a same problem. We are just avoiding race conditions. So in all these algorithms, we are just doing the same things. We have done a good job today. I know it's not an easy one, and it's, if you ask me, it's one of the difficult sections of this course. Try to make it easy for you, as easier as possible. But as I said earlier, you need to go through it a couple of times before you actually understand what's going on. So try to do it, try to debug the code yourself. It will make make it easier for you when you break it down for yourself. It becomes easier for you. Try to understand these concepts. They are very similar. They are not difficult at all. If you do it a couple of times, you're gonna master it, so don't worry about that. And yeah, I have an exercise for you. Practice, do it in your free time. Try to go through this exercise. Try to make sure that you understand, you implement it yourself. You can use my code. I'm gonna upload that for you as well. Even if I don't upload that for you, you already have that in the video. You can look at that. So try to do this practice exercise. If you go through this exercise and you understand everything, you do it yourself, and you understand what's going on, and you get the output, then I believe that you have done a great job understanding this one. So please do this practice exercise in your free time. As always, if you don't understand anything, please come and see me in my office hours. If office hours are not working for you, let me know your suitable time and we can figure out a meeting time, virtual meeting time for you. Any questions, please ask. Please do not hesitate. And last thing is assignment, don't miss. 10% marks that are too much, and obviously it can change your grade. So make sure you submit your assignments on time. Don't miss the deadline. Don't miss any requirements of the assignment, because there won't be any other chance to submit. So that's pretty much it, guys. I hope you guys understand all the concepts. I hope you guys go through the exercise yourself. Make sure you do a couple of exercises yourself. I know you have other courses as well, but this is the only way to practice. So wish you all the best, guys. Do good. I'll see you next week. Bye bye.